unit, whatever last unit we did was, tests are graded. And in your folder. They're pretty good. All right, that's going to be us later. Let's do estimation. All right.
300.
Thoughts?
300.
300. Who said that? Daniel?
Yep. 87.6.
Daniel says 300. Who said 87.6?
Herbie.
I didn't have more.
299.
299 says Derek. 160 said who, Johnny? All right, anyone else? Evan? 130?
Yes.
Anyone else? Xander?
500.
500. Anyone else? There is a video reveal if that makes you want to look. All right. Video reveal it is. I believe it is a time lapse. I don't know how fast the time lapse is, but here you go. 30 seconds of cheese ball fun.
If they start stacking vertical, I'm gonna get it. Yeah, that's true.
I don't remember. I will check. I think yes.
Damn.
Am I close?
No, you get a couple more in there.
Don't I with my cup.
I
I
think
think she was on the tour thing.
Just like at least.
Yeah, he had sorted them differently.
286.
Am I the closest?
I think you are, Derek.
Yeah, Derek. Yeah, thanks, Derek.
Derek is closer.
Look, I was gonna guess 99, but then you guessed 300. So close that.
All right. So, what we're doing today, we're going to go and do some separable differential equations. So, we're actually going to solve differential equations today. I will say this is a bit more of math than we've been doing so far this unit, but this is the last section of Unit 7. Let's see if it was on my grade plans. Yes, your Unit 7 test will be on this quarter. We'll be taking it on Monday, which means we'll get to round 2 next week. So I'm going to hand out these notes for you. You might notice at the top, it looks like there's a lot of stuff on here because I've actually shown you an entire problem all the way finished. You know, there's kind of 3 parts to these problems. So when you get this, I'm going to give you a couple of minutes to just look at it and tell me what you notice. I haven't taught you anything yet. So there's nothing bad to notice. I just want to know what you see going on. In these 3 boxes in the bottom, if you want to try to write what you think is happening in each step, you can kind of summarize it in a couple of words. You can try that. But I'm going to give you a few minutes just to say, what do you notice? This is a problem that is fully done. All right. So I'm going to give you 3 minutes. Be prepared to share something out with the class. So 3 minutes. You can look at part 1, part 2, or part 3. Find something that you notice. You could also notice anything in the question itself. You're looking at that problem at the top. It's already done. What do you notice? What do you wonder? 3 minutes to notice anything. You will share something. I'm going to cost someone a certain amount of that. Cool. Do I need to write your name on that? Or you can throw it? Cool. I'll be in there. Oh, that's fine. You're not the only one. I'm just getting more. All right. Have people noticed things? Writing some notes. You guys aren't talking anymore. Trying to figure out what's going on. There's a lot happening, to be fair. Did anyone see the rising freshman?
I heard that.
Scared.
I saw my brother.
They look scared.
I
They
wanted,
always look so scared.
I wanted to scare them. I wanted to like jump
Did
out.
they leave already? Are they gone?
That's true.
I was kind of stuck in a place where I couldn't see very sad. I normally
You got it.
aggressively say hi.
Like, they got a camera. They're the same way. No, that's next week.
Everyone has something to share. We all have something to share. We have to.
I have something to share.
Do you have multiple things to share? Hopefully.
Yeah.
All right. Everyone stand up. You may sit down when you impress me with your knowledge. So we'll work as teams. So your table may sit down when you have told me something of importance. So not like the paper is white. Herbie, what did you notice?
In part 2, they're just kind of like solving.
All right. What does it look like they're solving for? Perfect. Your table may sit down. Chris, what did you notice? All right, so there's definitely an integral in this process. Cool, you guys may sit. Leisha. Okay, so they're kind of splitting y's and x's. So y's here, x's here. There's a word we're going to use for that. Yeah, Daniel.
3, they're solving for 1.
Oh, cool. Here we solve for y. All right. Anyone want to add anything else? Should we do another round? Usually I have more tables than 4. What else did you notice? Anything? What did they use in part 2 to solve for c? Does anyone notice what they plugged in? Yeah, they use this part right here to help solve. That's called an initial condition. That's a fancy name for a point. We're getting to the chapter where they're going to use really fancy words. All right. Cool. All right, so let's kind of name these things. You actually did 2 of the names. This one is solve for C. This one is solve for Y. The first one I like to have a rhyming name. So what do you think, based on the name of these notes and what Leisha told me about putting the Y's on one side, X's on the other, what word do you think I'm about to use? Yeah, let's go with the verb form of that. So separate, and what rhymes with that we've been doing? Solve does not rhyme with separate. Integrate. So we're going to solve one type of differential equation, and that is one where we can separate the variables on both sides. Now, all of y'all are not named Zacharias. You are not doing multivariable calculus. So we have to create an integral that only has one variable on each side. We're going to integrate both sides. Did anyone notice anything kind of about from the integrals to this step? Something about the c that sometimes gets noticed. You guys notice how there's only 1 plus c? So we're going to only have 1 on the x side. You'll notice that as well. we will solve for C, and then we do want to get our final equation in like y equals form, like Daniel noticed. So we will be solving for y. Now, as you can see, these problems are 1, pretty darn long, and 2, pretty darn algebra heavy. So we're going to go through kind of very methodically and do a bunch of problems. The ones that I'm choosing are definitely harder, or at least I think so, than the ones that I put in your problem sets. So we'll kind of pause at some points to go back to the problem set to practice ourselves. I will say some of these are a little bit challenging, but you will probably see one of these on your free response on the AP test. So we'll practice. We'll talk about what points we would get. The one way to make sure you don't get any points on this question is if you don't separate your variables. If you don't split the y's on one side, x's on the other, I can give you exactly 0 points on this problem. So, are you ready to try? I can. While I do that, I will get my notes so I don't make any mistakes today. Everyone excited for grades? We still have this week and next week.
Why is it so late?
Easter.
Because
What? I don't know. I don't make the rules. Should I?
yeah, you should get promoted.
Oh no, that would be terrible.
Why?
I'm not very organized at all. It's not if you need to be superintendent. All right, so we are going to try this one. It's going to be a bit of stuff, but we're going to get through it. The language in these problems is pretty similar, but I will say this chapter, you're kind of using $5 words for 25-cent meaning. So we're going to consider the differential equation. This guy, again, is a differential equation because it has a derivative in it. We are going to find a particular solution. What that means is we want y equals stuff with x's in it. And the particular part means we're going to solve for C. If we didn't want to solve for C, we'd be looking for a general solution. That would be what without the kind of C being solved for. Then we are going to use the initial condition. Again, that's just a point. And they usually write it like this. Just keep in mind, though, the x is where the f of x would be. So that 1 is the x, the 0 is the y. So the first thing we are going to do is we are going to separate our variables. So we're going to think about what's on the wrong side. So for this one, we moved the y's to the left and the x's to the right. And that's going to be something we do every time because of how we have to kind of, and I'm going to use air quotes here, split the dy dx. Now the dy dx isn't really a fraction, but we're kind of treating it like one. It works with some of the ways dy dx looks. So I'm going to do a couple of things. I'm going to divide by this y minus 2 squared to get it to the other side. I'm going to keep the dy on the left, and I'm going to move the dx to the other side. Again, that's kind of doing a bit of hand waving over that because it's not really a fraction, but the way differentials, which are those dy or dx's, are defined, it works mathematically. We are. Yep. So my calculus teacher, AB teacher, used to say, if it looks like a duck and walks like a duck and acts like a duck, then treat it like a duck. I don't really know where that comes from. I don't know. I never thought about that until like just this moment right now. All right, now things that usually have our dx's on the end are usually integrals. It makes sense to put an integral here as well because we are trying to go from a derivative back to an original function. So one would think that an integral would be a good place to go. Now, a lot of the times, one of these integrals is going to be quite a bit more difficult than the other. I would argue the one on the left-hand side is a little bit more challenging here. How could I rewrite this guy to make it a little bit nicer? Perfect. I would love to bring this up as a -2. I can't use natural log here, even though a bunch of people would want to, because that power of 2. Now, technically, this should be a u sub, with u equals y minus 2. But the du would just be dy. So there's no constants to take care of. So I'm going to kind of just treat this like one entity together and just do power rule on that. So when I integrate, what do I do to the power? All right, I add 1. So what would my new power be? -1. Because I am silly. Thank you. Because I was thinking very hard of the power I wanted it to be. All right, and then I need to divide by the new power, which was -1. All right, I'm going to put my equal sign, and I'm going to integrate on the other side. Since this one's easier, what do you guys think the integral is on the other side? Cool. Where's Herbie getting the 1/6? Anyone know where this 1/6 is coming from? All right, yeah, we're doing 1/3 that was there times the 1/2 from the 1/2 x squared. Now, I'm going to put a constant on this side. So there's only going to be 1 plus c, and I'm going to keep it on the x side. The reason for that is I could have multiple constants, but they would be different. So I could subtract, and I just have one constant on one side. Since we're eventually, like Daniel said, going to be solving for y, I kind of want to just keep everything as far away from the y's as possible. What? Putting the plus c just on the x side? Yeah, we're going to do that every single time. So you essentially could have two different constants. So I could have like c sub 1, c sub 2. If I subtracted this to the other side, all of this is still a constant. So we're just going to treat it like there's one constant that I've already combined together. Whee. All right. Now that we've separated, we've integrated, what was the next step from our 3 steps up above? Solve for c. Now, these technically can be done in either order, solve for c and solve for y. The reason we're going to do it in this order is it generally maximizes our points on the AP test because there's a lot of points they give you for trying to solve for c. I'm going to do it in a different color so that we can see the difference. Does anyone have a color preference? Orange, I heard a bunch of. One of the fun colors. How about ocean? All right. What point or what initial condition am I plugging in to try to find C? All right, 1, 0 is coming from the top. Does it? All right, as I plug in, let's kind of think about what's going on. All right, so I've got negative, what was the y? 0 minus 2, so -2 to the -1. Wow, that's going to need some simplifying. I've got 1, 6, x was 1 squared plus c. All right, I want you guys to take a second. I want a singular number said back at me. -2 to the -1. Simplify it. I'll come back to you in a couple of seconds. It could be -2 over. It could be. I just kept the. I brought this up. All right. What do we think the number is? All right. So I think these guys right here, those two negative signs, will make it positive, right? What does to the -1 power mean? Yeah, so my -2 effectively needs to go on the bottom. So I've got -1 over -2 or 1/2. All right. So I've got 1/2 minus 1/6. What does that equal? 1/3. That works because it's 3/6 minus 1/6. That's 2/6 or 1/3. So that algebra can be nice. It can be messy. It can be whatever we want. We are 2/3 of the way done this problem. Everyone excited? All right. Anyone have a final color they want? Lava. Wow, you guys are making this problem a little too fun over here. All right. What's our last step? What do we do? What was the last step? Solve for y. So what I'm going to do is I'm going to take this step right here, wherever I plugged in my point. I'm going to simplify this guy a little bit. You guys did that -1 power was like bringing that to the bottom. So I'm going to bring the y minus 2 to the bottom and put the -1 on top. Spooky noises. All right. And what? We're solving for y now. Because I kind of just don't want to have this -1 exponent right here. I'd rather be able to solve without any exponents there. So I'm moving this back to the bottom. Yeah, because the negative sign, it doesn't really matter where it is as long as there's only one of them. All right. Instead of plus c, what do you think I'm going to write? Plus 1/3. So I'm going to use this guy that I just found as we go. Now, this is not my favorite equation to solve, but this is the only thing I have to do in this problem. I'm not being asked to do anything else after I find this equation. So I'm going to leave it as gross as I want. So what are your thoughts on getting y by itself? What would you do? Yeah. What? Because we eventually want our particular solution, just like up here, is going to be a function of x. So y equals something with x's in it. So we want that variable still there. I needed to put this negative sign somewhere. All right. What should I do now? I'm solving for y. When you're solving for y, do you like y to be in the denominator? Okay, so let's multiply both sides by y minus 2. So that'll get rid of it on one side, move it to the other. All right. Can't really transfer the 1/3. Could transfer all of this via what operation? I could divide. So I could have y minus 2 equals -1 over that big old fraction. Now, again, I don't really care about simplifying this, so I'm going to just leave the fractions in the fractions. I don't really care unless this is multiple choice. What is my last step to being able to do this? Add the 2. So I'm going to put the 2 out front personally. You could put it at the back end. Doesn't really matter. And I get this beautiful function. Now, we did a lot of steps. So let's think of what we found. When we're finding a particular solution, we are trying to find a function, so y equals stuff with x's in it, that has a given derivative and goes through a specific point. Now, it's hard to check the derivative part of it, but you can check that your point goes through the right part. So I could plug in 1, make sure I get 0. We're going to do that a lot later today to make sure we can get the right function. What I would like you to reflect on as we do some of these problems, I know they're going to be difficult. We're going to walk through them the same way, but I want you to notice that the problem is really like algorithm based. We're going to be doing the same steps every time. So it's going to be the same steps. We just have to be careful with within those steps as we go. So let's do, I would love to try at least one more, and then maybe we'll take a break. Maybe 2 more. You got 2 more in you? We'll find out after the next one. All right. Cosine. Wow. All right. What's on the wrong side? All right, we've got dy dx equals 3 minus y times cosine x. We've got mixes of x's and y's on both sides. So I know I'm going to want to move the dy dx, wow, that was fun, to this side. What do you think I'm going to move to the other side? The y, and I'm going to have to move the whole factor. So I'm going to have to move the 3 minus y. Yes. So the dy is going to stay on the left. Dx is always going to go to the right. So I'm going to do 1 over 3 minus y dy equals cosine x dx. Yes, exactly, Sachi's right. We're going to add the integral in there. All right, does anyone see a problem? You don't? Do you see a problem? It's U sub. Where's the U sub? So this one, we have a function inside another function. The reason we are going to have to actually look at that U sub is what is the derivative of the bottom of this function? -1 dy. I don't have that -1, so I'm going to move it to the other side, and we can actually do this substitution. So in the last one, I didn't really do that U sub because I just had du equals dy, so I could treat that like its own thing. Here, I actually do have to keep track of something. So I'm going to make this substitution, putting -1 over u du, and then copying down the right-hand side. I kind of try to make sure that I integrate at the same time on both sides. All right, I know the negative sign is staying. Does anyone remember how to integrate 1 over u? Nice, natural log. What goes inside the natural log? Absolute value of u, which I'm going to go ahead and just plug back in my 3 minus y. All right, anyone know the integral of cosine? The positive or negative sign? Normal sign, because the derivative of sine is positive cosine. Perfect, plus c. Now, usually these problems are worth either 5 or 6 points, depending on the difficulty of the integral. This one with the u sub might be worth 6. So at this point, we've probably earned 1 for separating and 2 points, 1 for each side of this integral. With this plus c, if we plug in our point for the next step, we will earn the 4th of 6 points. What is our point that we're plugging in? Our initial condition. Which way does it go? Is it 1, 0 or 0, 1? 0, 1. So I'm going to use a different color since we're in the second step. What should our color be? I'm kind of feeling pink. How does everyone feel about that? The sparkly pink. That's like real light colored. I'm going to go bold. All right, so 0, 1 going in. All right, so negative natural log of 3 minus 1 or 2. Wow. Yep, this is our second step. So we are solving for c. All right, I'm putting sine of 0 plus c. Now, no. What is sine of 0? 0. So c is negative natural log of 2. What a beautiful number. Yeah. It's not a nice number. All right, we separated, we integrated, we solved for c. What's our last step? Find y. We're going to solve for y. Now, this one's going to be a little weird. Get ready. So I'm going to take this guy where I plugged in to find c. And I'm going to put the c back in. So sine x minus natural log of 2. All right. I'm going to try to get the natural log by itself. What's in front of the natural log that I should get rid of? The negative. So I'm going to remove that. So I've got negative sine x plus natural log of 2. How do I get rid of natural log? What's the opposite of natural log? My favorite function. E to the x. So I'm going to exponentiate or e both sides. It did. Why is it so annoying? You don't like having inverse functions to get rid of things? No, you're noticing probably that I did not drop these absolute value bars. Something has to happen when I drop those absolute value bars. It's the same thing that has to happen if I make a square root in my equation. What pops up in front of that square root when I have when I make a square root when I'm solving an equation? So I've got, if I square root both sides, what goes in front of that square root? Plus or minus. So when I remove these absolute value bars, I actually get the option of having positive or negative, this guy right here. And I will have to make a choice in that solving process. I'm going to go ahead and solve for y just to get it all by itself, and then we're going to make that choice at the end. Yes, there is. All right, so I'm going to add y to the other side and kind of subtract this. What? Because we have to solve for y. It has to be y equals at the end. Because that's not how absolute value bars work. All right, so I'm kind of adding y to both sides and then subtracting this big thing right here. So I'm going to get 3 plus or minus e to the negative sine x plus natural log of 2. So this is a big, nasty function I don't really want to work with, but I do have to work with enough to make the right choice of plus or minus. Now, we know that this function has to go through one very specific point, and that is the point 0, 1. So if you have a plus or minus pop up, it could be from you taking a square root. It could be from you doing absolute value bars. You're going to want to take this point and try to plug it in. So we have 3 plus or minus e to the negative sine 0 plus natural log of 2. What did you guys say sine of 0 was? 0. So 3 plus or minus e to the natural log of 2. What did we say e did to natural log? Got rid of it. So this is 3 plus or minus 2. If I'm supposed to get 1, do I choose plus or do I choose minus? Minus. So my answer is going to be y equals 3 minus e to the negative sine x plus natural log of 2. Am I going to simplify it? No, because I don't need to. Because that's what made the initial condition work. So we plugged in our initial condition 0 for x, and we were trying to figure out which one got me the right y value. So this was supposed to equal the y value of 1. So to make it true, I needed to choose this. All right. Do you think you would benefit from pausing to try a couple problem set problems on your own?
Like with this?
Yeah, with this. Or do you want to keep rolling together for a little bit? We should do it. Do what? Problem set problems? You want stickers? Yeah, I'll roll around with stickers again. So can everyone find their problem set? I want to find you just one to try on your own. I will say the ones in here, I believe, are definitely easier than the ones I've just been doing on the board. Let me make sure I have one where it's kind of a nicer question. So our goal is going to be to try to get one of these done in the next few minutes before we take it. Let me choose which one for you guys. All right, so I'm going to give you 2 to try. I would make it your goal to get at least one of them done. We haven't done one that's super similar to 18 yet, but you could definitely do it. The ones we've done that are kind of similar, 15 is kind of similar to the first one we did. 17 is kind of similar to the one we just tried. You're going to need to use some E there and have to choose between the plus or the minus. Herbie is right that the other one that you can do is 18. So I would like it to be your goal to try to get at least one of those done in the next, how long do you think it'll take you? 20 minutes? That is way too long. Lucky set. Here, I went to 8. Try 8 minutes. So as many as you can done from 15, 18, 17, whichever ones you want. You could also pull out your slope field questions if you're getting scared. Mhm. You can. We haven't done one. It's supposed to be like 18, but 15 and 17 look a little bit more similar. You actually don't have to. What I would do is kind of like what we did here. Through it as a negative 2 for us. I like that idea. And then be careful on this side. See how that was in the denominator before? It's got to stay. You can, or you could do like 1 over x minus 1 over. Herb.
Yes, you put your neck.
I do. I would try to always put your y in the left. Right, so that x may stay as the denominator. I'm going to do the line. So that one has a different linear bond, but also makes
Why replace it once?
that's how you do 2 things with it. But I do want to bring it. Yep. Let's see how we can. So you could think about it. What would the derivative of the bottom? It would be 1, right? So you don't really have to pay attention to the x with constant. You're going to end up with just this one. Yes.
Or no, I'm not there. I'll pop on.
Which log is 0 is undefined? What the? That is right. Love this side. That one is gonna look more like when I have. Well, that is this. You have this one do like 1 over just like a single variable. So that is gonna be a lot like natural log. Now here, the derivative of the bottom is -1, so actually it's a little bit easier. What's the derivative of the bottom of that? 1. So you're just gonna end up kind of getting natural log of fewer at the bottom.
And is the bottom is 1.
Bottom is all.
Natural log of x minus 1.
Yes. And then you're ready to solve for C. I don't like how you separated your variables. The y squared is on the top over here, but if the y is also on the top, you're going to
And then X minus 1
Oh, but you got the C. Oh, see?
Yeah, you can also one.
No, because I had Y straight, so they should be negative.
I would argue no,
Right?
because what power would it have to be? And what happens by that? So.
It should be one over Y. Oh, you probably subtracted.
Not necessarily.
Yeah, you gotta
are
have
going
it.
to be solving for
Because you
okay, so do you know what natural
You
number
gotta
is?
take the little one number two.
You can start with the X.
Oh,
Yeah.
no, it could be negative one. Right?
I like it in natural number.
No, you gotta,
Size somewhere, might be a
well, you multiply by, one over.
Oh, well,
I'm just trying to set it.
yeah, I like that. I don't like that.
Pretty.
I would just keep 1 over x minus 1. And then if you're looking for kind of inspiration on that guy, how we did this interval right here, where we had a y to the single power on the bottom, doing the similar to how we did x to the sine power. So it might be a little bit different. I would argue the same.
So that's my top like two.
Is this 1 blocks over 91?
No, so break it down.
I just wrote
I'm like,
Oh, okay.
Well,
Right.
how beautiful. So that's like here are wider in the future.
I'll take that.
You don't want the baby next to you. Fun fact, that was real.
I don't like it. Then I don't take calculus next year. I think so. So,
They're getting real.
well, I think I've taken standard listening, which I'm like.
One more time?
All
All right, on one hand.
It's like a listening section. Maybe 4.
All right, I'll go 4 because Johnny asked nicely. It sounds like she wants to go.
No, I'm.
All right, so 4 minutes if you want. I think 17 looks very similar to the one we just did in the notes. So if you want to try a second one, 17 is great. Or if you want to take a break with your brain, try that Scorpio.
So, you got like,
Very similar to how we integrated.
so like, whatever, like, 0, 0.
This guy right here,
And then that's correct.
because you won't have to pay as much attention to because the derivative of
Like that. Oh, you need to erase everything. I got it all. Alright, start again. Hey.
Yeah, what are you gonna do now? Cool.
Guarded, like. Yeah.
But yeah, you're Yeah, this is a relatively popular.
I don't understand. I shall be here. Those clubs should be left in front. I
All right, this guy is not this guy. The Y.
Because there was multiplied together.
I feel like I pulled too hard of problems. Oh well.
Oh, I didn't think about
So you're divided by 2. No, I'm divided by 5. And then I'm multiplying by 5. I cross those 2 out.
Alright, only one of you wants to stick.
Yeah, so another one, no. Yeah, but I do like, I don't. Let's see. Yeah, let's see.
Oh, and that's it. Oh my god.
Oh, I stopped. I originally had it work.
I think I did it.
You think you did it?
Oh,
It's no, you don't have to be like I like it here. You can solve for no, so you can shape it like that if you want, but it is so I would well, I just yeah. All right, I want you to pause wherever you're at. We're going to try a couple more just to see if we understand. And then I'll let you keep rolling. So, what is natural log of 1? I don't know. Use a calculator. You got a ton of them behind you. I lied. I do know. I don't know why I told you I didn't know. All right. So I want to try 2 more. These ones are not quite as bad as the first 2 that we did because they don't involve use up. Let's go ahead and we're going to look at this guy right here. What? Left side above the one that says log. All right. So help me out. I am trying to consider this differential equation. I want to find the particular solution with the initial condition. Has everyone kind of seen the same words over and over? We're finding a particular solution with an initial condition. All right. What's on the wrong side? I would argue there's 2 things. All right. The dx I want to move. What else? The what y? Oh, the y cubed. All right. How do I move the y cubed to the other side? Okay, I'm going to divide by y cubed. And then I'll, using strong air quotes, multiply by dx. All right, how do I get to multiply the 1 over y cubed? Does that one use natural log? No. How do I have to do that one? Y to the negative third. We're going to bring it to the top. Again, I'm going to leave those guys unintegrated until I can integrate them together. All right, what power is y going to be to once I integrate it? -2. I was like, how are you adding 1 to that? Oh, the -1/2 in the front. Gotcha. All right. What's the integral of x? Cool. What else? Anything else? Am I done? Plus c. All right. Step 1 done. We separated. We integrated. There's a lot of like sound effects happening today. Congrats. All right. Now what should I do? All right. How do I do that? There's a lot of letters. All right. What is my point that I'm plugging in? 1, -2. So let's plug this point in. I've got -1/2. Let's rewrite though y to the -2. What does y to the -2 look like? 1 over y squared. So let's do 1 over -2 squared. Generally, we're going to be moving a lot between negative exponents and positive exponents on the other side of a fraction. That's going to be something we're going to want to be comfortable with. All right, we have 1/2 and my x is 1 squared plus c. I didn't leave myself near enough room, so I'm going to roll back up here. All right, this fraction on the left-hand side, I've got -1/2 times, what is that, 1/4? So I'm going to claim -1/8. Do you guys like that? 1/2 times 1 squared is just 1/2. Explain. Where are you talking right here? So I use this negative to put it down in the bottom, and then the negative on the -2 is getting squared out. All right. So I need C to be whatever -1/8 minus 1/2 is. Anyone know what that fraction is? Like it. So -1/8 minus 4/8. All right, we've separated. We've integrated. We plugged in our point. We solved for C. What else do I have to do? Solve for y. So I'm going to roll to where I plugged in to find C. Now, I know I moved this down when I made this fraction. You know, okay. And that was painful? I guess you're tall. Why don't you grab one of the tall desks? Okay. Evan has a tall desk. There's no like basket under yours? Or what do you even call that? Cubby? All right. All right, so I'm just plugging my C back into this equation and trying to solve for this guy. Now, let's say I did want this to not look quite as gross. For this one, I thought I might as well simplify a little bit just because it was getting a little obnoxious. So tell me if this is legal. I would like to multiply by something to clear all of the denominators, except I'm going to keep the y squared where it is right now. What could I multiply by to clear all the like numerical denominators? 2 would clear 2 of them. What about that 5/8 though? Yeah, let's try 8. So this is kind of an optional step. I just wanted to make this look a little nicer because it was just looking really obnoxious. 8 over 2, that's going to give me 4. 8 times 1/2, still going to give me 4. And then -5/8 times 8, those 8s are going to cancel, so I'm going to get -5. Here. All right, now I'm going to do that thing where I did before where I kind of multiplied by y squared to get rid of this and divided by the other thing, that thing in parentheses. So I'm going to get y squared equals negative 4 over 4x squared minus 5. Yes, I take the square root. What do I need to be careful of, though? Something's going to pop up right here. A plus or minus. Here we again are going to have to make the choice on the plus or minus. There is a wrong choice. All right. How did we make the choice before? What were we looking for? All right, cool. So we look at our initial condition and we think about if we plug in x is 1, which one is going to give us negative 2? I would argue it's pretty easy to see since we have y equals just the square root with a plus or minus. Which one are we going to need to choose for the minus 2? Will we need the plus or the minus? The minus. I love when I ask you questions. Literally no answer.
I try to catch.
Okay. All right. So we are gonna have to choose the minus to make this true. So our actual answer will be y equals negative square root negative 4 over 4x squared minus 5. Again, aggressive. All right, what I would like to do is do this very last one, and then we're going to pause again to work on our problem set for a little bit. Again, the ones on the problem set are easier than the ones that we're doing, but let's do this last one because I know how much you guys love trig, and I wouldn't want to take that away from you. Yeah, it's not that bad. All right, what's on the wrong side? All right, the y squared. I'm going to pull just the y squared to the other side by dividing. What else am I going to move? D theta. Am I going to turn the theta into x's because I'm scared? No, I'm just going to keep it theta. It's a nice variable. Looks like an Easter egg. How festive. All right, let's slap on those integral signs. You can probably guess what I'm going to do to the left-hand side before we integrate. Can you guess? No. Bring it to the top. What's going to happen to its exponent? Make it negative. There's so much worse variables than theta. Omega. Epsilon, delta. I don't like lowercase delta very much. There. All right. How do I integrate this one? What's it going to look like? I know there's a y. What power will it have? -1. And I'll divide by -1, so it'll have a negative. The 2 is going to chill out. What's the integral of cosine? Sine. Theta. All right. I'm good, right? Cool. Ready to go? Plus c. The plus c is really annoying if you forget it in this step because the rest of it doesn't really work. You need to solve for c in the next step, so we gotta be able to do that. All right. Now what? We separated. We integrated. We plug in our point to solve for c. All right. When I plug in on this side, that negative exponent is going to move me down to the bottom. But I am plugging in 1, so it's not super terrible. 2 sine of pi over 2. We haven't really talked about pi over 2, have we? It is. All right, so pi over 2 is this angle right here. Yeah, exactly. So we're kind of working with theta comma y instead. No, it's not at all. It does. All right, so sine of pi over 2 is the y value at this point. This is the point 0, 1. So we have 2 times 1. So Herbie is right. C is -3. All right, we're 2/3 of the way done. Maybe. But I'll explicitly remind you right before the test, like I always do. All right, you guys remind me. I've separated, I've integrated. I plugged in my point, I solved for C. Solve for Y. Where should I go to solve for Y? All right before I plugged in. Can I rewrite that thing in the blue circle though? Make it look a little better so I don't have negative exponents. Put it on the bottom. So negative 1 over Y is 2 sine theta. And I feel like I shouldn't write plus C. What should I write? Minus 3. All right, now we've done this flip-flopping of denominators quite a bit at this point. I'm going to essentially multiply by Y to get rid of this divided by Y and divide by everything else. So I've got Y equals negative 1 over 2 sine theta minus 3. Yeah, we don't need to do anything after this point. Honestly, there's not much you can do to this guy as we go. Again, if you're keeping track of like points on this question, separating is 1. So if you're on the AP test, if you don't think you can do anything else, at least separate your variables. You're getting a point there. Then you're probably getting either 1 point for both the integrals or 1 point for each of the integrals. The fourth point is really cool. You get it for just doing plus C and literally plugging your point in, even if it's not right at the C equals whatever. If you do plus C and plug in your point, you have another one. And the last one, solve for Y. So that last point is the hardest one to get as we go. All right, what I would love to do right now is give you kind of an extended amount of time to work on your problem set. So again, we have the same goal questions. I would say a good one to move to next would be 18. So you're looking at 3 questions in particular. I'm going to give you more than enough time. So if you want to spend some of this time kind of using it as a break, totally fine to do. Your goal is to get 15, 17, and 18. As much of those done as you can. I'm going to roll around with stickers again. Let's go ahead and take, how much time do I need? We'll do 12 minutes. To keep going. If you want to take a break during that time, you can. If you want to just work during that time, you can. There we go. Yeah. If you don't remember that on the AP test,
I can't.
Oh, I don't know.
Oh, there we go.
anything that can effectively be plugged in, you know, without like having to go in the menu. What about so let's say you're on the previous one, so you don't know it's not apply over to it.
That's right.
But I know that.
Yeah.
That's the only thing I remember.
No. We're faster together, but they're like I walked by here.
I know.
I was gonna make the freshman stop.
17 is probably.
Oh, yeah.
That's right, you were. It's all that, that's all.
Now it's like one.
We'll see what else that.
Yes, yes, that's the one. 17.
I usually do.
Yeah, that's my English teacher did. So it's really like English. So I was like, hey guys, I was like, this is for Oxford right now. Probably like
So.
How 16 like pretty easy compared to 15, 17. That's the way that answer.
I don't think I can have the full one.
Because,
At least one of these should be so realized.
yeah.
That's a lot of tools.
Yep, sorry.
Yeah.
I like the actually values. Oh, wait, you have brain. You never had so I studied morning.
That's what it's.
Yeah. So what I would do for
I'll be the answer to that.
I will.
so I would figure out a lot of it, and I really want to try to make it.
I know, it's like.
But you're like plugging this line or get rid of
You are? Oh, that's. I thought that was. What?
No, I thought that too.
Okay, that makes sense.
City.
Yeah.
That was like. I mean, it's a month.
Yeah, no, I did the same thing. Oh, yeah, these ones on the back.
Well, yeah, that's this part. Like, no, I wasn't gonna do like.
I thought he was fine.
Well, I do it. That's fair, that's fair.
No, I mean, that's fine for it. I don't know the next
Oh, that's fine.
I didn't get one of that fancy soda do that.
What does that mean?
I didn't get one of sparkly.
Oh, God. Okay, get another one right. Maybe sparkle.
Why? What did you ever?
Still, the problem you're running into is the power would be 0, right?
Yeah.
So the answer to that is always the same.
Okay.
The best of my
It's
knowledge.
fine. My basic calculus students forget all the time. It's just a thing. All right, T minus 4 minutes until I show you one more thing. It's a relative. So this is your with light. With the same light. See how you have flying.
Why do you keep it there? I want my light.
Oh, I keep dropping my answer, I'm getting my steps in. Why are you saying sorry? I'm the one who is making this here. I'll get home. I don't like that one.
So for 12, would there be natural logs in the answer?
No.
No.
So natural logs only pop up when you have a linear thing in the bottom. So sort of like a power, it's a really common.
I knew I did that.
Oh, I didn't know that, did I? Oh, I can't believe I did that. There.
So we don't have a product.
This can be done at
Yeah.
Oh.
I get out so a long day right there.
I use it straight.
You use a ruler?
Well, I know I used a bit on my calculator. That's straight.
Figure out.
And this is junior.
Now, how do I find it? I checked. I remember the rookie days. I
Just.
She usually gives us a call. Yeah, so it's my next bar. I'm glad we have it on here. Yeah. Because I say, I need to.
Give me like a Scotch.
How do we get three? Oh, yeah. Oh, okay. So why not?
You know, it can't be like the last one.
I mean, it is actually like, if you record it with like 9 years, it is wild. Absolutely wild. Like,
So I have plus or minus 2.
no, it's like, when you use like, you there, so you're doing like,
Yeah, these ones are a little bit, the words are a little bit easier to play, but essentially you just want to make sure it's that. Oh,
I don't feel
I was looking close though. So I would want. All right. I would almost all that. Only thing I don't like, so I move this one half to the side. How could I get, instead of like, you could divide by 1/2, you can multiply by the reciprocal.
Oh, so it's
This should be it. Other than that, literally love it. Love your choice of negative, it's perfect. Right? And that's about the difficulty level of the ones that I would put on the test. And we're not going to have very many. So if you're comfortable with that one, it's good. Nice. That's awesome. All right. So I would like to end class showing you one special differential equation. So we're going to go back to the last page of the notes. If I finish this last back page, I will be done talking for Unit 7. Wow. Yeah, so next class is we'll do a little schedule talk at the very end of today. Next class's notes are probably one of the shortest notes we'll do all year, because I'll be able to teach you what we're learning that's new in about 2 minutes. Then we'll just practice. All right, so there is one special differential equation that I'm going to show you. We're going to use it to solve one problem about a puppy. So we actually wrote this differential equation last time. So the rate and change in population, I'm going to call that population Y just to be easier, because we usually use Y equals stuff, is directly proportional to that population. So how do we usually write a rate of change of something? In calculus, sorry. Yeah, we're going to do dy, and we're going to do it dt because we're doing it with respect to time. Does anyone remember from what we were doing last time about the directly proportional stuff? What did we use for that? There's like a letter. Yeah, we used k, and if it was directly proportional, that variable was just there. Now, I'm going to try to solve this differential equation. I know there's going to be a lot of letters. I'm going to need you to trust me, though. So what's on the wrong side of this differential equation? Y. I'm going to divide by it. What else is on the wrong side? dt, I'm going to quote unquote multiply by it. All right, you guys have done this a bunch today now. 1 over... think of the dx's. I've been moving those to the right-hand side, right? Yes. So here we're going to use our x variable is going to be kind of like time, so I'm using t instead. All right, this side, we've been integrating a bunch of things that look like this. 1 over y, 1 over x, 1 over whatever. If it's to the first power on the bottom, who comes to the party? Natural log, absolute value of y. Now, this is like a number. So when I integrate like the number 2, what do I get? 2x, or in this case, 2t, or in this case, kt. All right, what am I missing? Plus c. Now, do I have an initial condition, a point to plug in to find out what c is? No. So in this case, I'm going to be finding what's called a general solution. So it's still going to have c's in it. So I don't have to solve for c. What was the last step of what we were doing? Solve for y. So what can I do to get this natural log to go away? E. Yeah, wasn't that a meme for a while? E. All right. So I'm going to do y equals, I'm going to drop the absolute value bar. So I've got plus or minus e to the kt plus c. Now I'm going to tell you, this actually is an equation that you might have seen in Algebra 2. So I'm going to move it around a little bit. All right. How do I get addition in exponents? What do I do to get addition in exponents? Yeah, I multiply them. So like x squared times x cubed, I would add these exponents, right? So I'm going to argue that this is the same thing as plus or minus e to the kt times e to the c. Would you agree? All right. No, we only need one plus or minus because everything's just being multiplied together. But let's look at all of this. I will tell you. All right. Is E a number? Yes. Is C a number? Yes. If I make it plus or minus, is it still a number? So I'm going to call all of this a letter. I'm going to call it P for reasons that are going to become apparent in a second. Apparent. So I could write this as y equals P e to the kt. Yes, some of you might have seen this with the k replaced with a different letter. P e to the rt. Hurt? Did anyone do compound interest in like Algebra 2? Okay, cool. This is a formula that comes up a lot in Algebra 2 classes. Sometimes when we talk about things like compound interest, if you have looked at that before and you saw this formula, it comes from something that's very algebraic. And then all of a sudden they're like, if you compound continuously, it's this, and it has an E in it. And I remember as a wee Algebra 2 lass, I was always very angry at why the E popped up. So this is why. The cool thing about this is if we know this differential equation applies, we can immediately jump to this solution without having to do calculus. So I'm going to show you what that looks like in approximately 1 second. So if we can see that this differential equation is what we need, we can originally just straight out the bat go to PERT. So we're going to look at the very bottom problem of this and try to do it before we leave today. Doesn't really matter. I was using PERT because some people in the past have had that memorized, but whatever you wanted. I had 1 year they wanted to do RE to the KT, so they called it rect. And then they wanted me to get a pet cat, and we were going to call it rect, and another one called PERT. Speaking of pets, here's an actual test problem off the AP test. We got a puppy. He weighs 2 pounds at birth. I'm going to start making points. So 0, 2. So I'm going time, comma, puppy. He weighs 3.5 pounds 2 months later. So I'm going to do 2, 3.5. Now, here's the sentence that tells me everything calculus related. If the weight of the puppy during its first 6 months is increasing at a rate proportional to its weight. So that means the rate of change of the puppy is directly proportional to how much puppy there is. If you have that situation, the rate of change of the money in your bank account is directly proportional to how much you have in your bank account. The rate of change of whatever is proportional to how much is there. Half-life is a good one in chemistry. The rate of change of the chemical I have is directly proportional to how much chemical I have. This sentence tells me I can use PERT. And that's really the only calculus in this question. All right, I want to know how much puppy is there at 3 months. All right, let's talk about what point to plug in first. I'm going to plug these points in. Which one do you think is the easiest one to plug in? 0, 2. So I'm going to do 2 equals PE to the R times 0. That's 2 equals PE to the 0. What's anything to the 0 power? 1. So P is 2. That actually makes sense. The P actually stands for principal. I don't remember which PLE, PAL. The initial amount. PLE? It's the initial amount. So if you want, since this is 0, this is always going to be P here. So I plugged in 0 for T. All right, now I'm going to plug in 2, 3.5. So 3.5 equals, I'm going to use the P I just found, so 2, E to the R, and what am I plugging in for T this time? 2. All right, I'm going to divide by 2 first. Oh gosh, there's an E there. How do I get rid of an E? Natural log. We are solving for R in this step. R is going to give us that constant that's up at the top. Eventually, we're going to plug in to find Y, but we have kind of a middle step. So I'm going to divide by 2 here. I'm going to do it with a 1/2 just to make it look a little bit nicer. And for my very last step, I'm going to plug in the P that I found, the R that I found, and this 3 to get me the value of Y, which is my puppy weight. So my P was 2. My E was E. My R was this number here that I'm never going to round. And my T was 3. Notice I plugged in everything on that side. I'll run and get a calculator so we can see how much this puppy weighs.
46 pounds.
I doubt that is the answer.
403 pounds.
4.630 pounds. You can kind of tell. You can sanity check your answers. We can do one next class. So, favor before we leave. It will be on the test, but let's talk about schedule. Can you guys not ignore me because we only have like 30 seconds left?
Yeah.
Wah! All right. So, looking at our schedule, we're doing 8.1 next time. Literally, probably the shortest notes of the year, and we're gonna be very calculator focused in Unit 8. So I'm going to build in some time to work on our problem sets next time, because also what's true about our problem set? It's due next time. So I'll give you about half an hour, but make sure you are coming with most of it done. Problem sets due next time. You'll have half an hour. Thank you.